In question 3, we have a bead on a smooth fixed circular hoop. It starts at C here and it's projected with speed to square root of 10 GR. This is its speed. It reaches D and it coalesces and impinges. It comes together with another bead. So we're going to have two masses combined at D and show the combined mass will not reach C. So we need the speed at which it leaves D at. So let's have a look here. So energy, let's have a look at mgh plus a half mv squared at position 1 and position 2. So at position 1 we have m times g times h, which is two radiuses above d. If we take d as 0, so we can take the height here as 2r plus a half times m times 10 gr if we square root of 10 gr. So we have 2 mgr plus 5 mgr. So it's given in terms of mgr. We have energy at position 1 of 7 mgr. So let's have a look. It needs to be equal to position 2. So at position 2, we go yellow. Position 2, mgh is going to be m. We won't go yellow, it's very hard to see. mg0, this is at position 2, plus a half mv squared will be equal to, well, it'll be 2 mv squared now, won't it? Well, it will be 2m when they combine in a second. So let's have a look at half mv squared. So that's equal to mv squared over 2. So we divide by m, multiply by 2, we get 14 gr is equal to the v squared. So the square root of 14 gr is equal to v. So now if we apply conservation of momentum, m1u1 plus m2u2 is equal to m1v1 plus m2v2, which is going to be v1 as well. It's going to be the same speed as they coalesce. So we have the new speed, we have m, they're both m, so m by the square root of 14 gr plus the second one, well, that's starting from rest, so we have a 0. Then we have 2m times the new speed of v. So we have 2m times, well, actually if I leave it as 2m times the new speed, m2v2, that should really read. So we have 2m times my new speed, v1, and then 2m times overcomplicated, it's just 2m times the new speed. So we have, if we divide by m, we have the new speed that they're going to travel at before, then I can apply the speed when it's going to be 0. It's going to be the square root of 14 gr divided by 2. So now we have the speed it's going at, so it's going in this direction. It's a mass of 2m. We have a new speed, and then it's going to hopefully not get to the top, so we have to show that it's going to reach a particular height up here. So let's see what this height will be. It has to be less than 2r. So mgh, if it starts at 0, plus a half mv squared in position 1 is equal to mgh, that's the h that we're looking for, plus a half mv squared. This will be 0 in position 2. So position 1, we have 2m times g times the h, which is at this point is 0, plus a half times 2m times v squared, which is 14gr. On top it'll be 4 on the bottom. This will be equal to 2m gh plus a half m by 0. I think this is right. So we're going to get 7gr over 2. 7gr over 2 is equal to 2gh dividing by m divided by g, and then divide by 2. I'm going to get 7r over 4 is equal to my new height. And what do we not want it to travel? We don't want it to travel the r, and the other r has to be less than 2r. Yeah, this is less than 2r. Therefore, will not reach the top, which is what we were asked to show.